already learned about limits at infinity, where when we have a constant divided by infinity, you will get 0 as your answer. Now, we want to focus for a rational function. It means that your limit would be infinity, but then you have a rational function, and after the substitution of your limit value, you will get infinity over infinity as your final answer. This will classify as indeterminate case. So we have once again to manipulate the function to find our real answer. Our concept here is, if we encounter this situation, we have to divide the numerator and the denominator by the highest power of the denominator part. Let's do some example. Example 12 part A, we have to find the limit of x approaches positive infinity of x plus 1 divided by x minus 2. If we directly substitute, we will get infinity plus 1 divided by infinity minus 2. So this can be simplified as infinity over infinity indeterminate case. Now we have to manipulate our function. Our concept here is divide our numerator and denominator part by the highest power of denominator part. In this case, our highest power will be x. So now, limit of x approaches positive infinity. We just copy it back. For denominator part, we divide every single term by x. So this would be equal to x over x plus 1 over x divided by x over x minus 2 over x. After that, try to simplify your function. X divided by x is basically 1. Now, rewrite back your simplified function. We have x approaches positive infinity of 1 plus 1 over x divided by 1 minus 2 over x. Now, once again, try to substitute your limit value into your function. So this would be equal to 1 plus 1 over infinity divided by 1 minus 2 over infinity. In previous lesson, you already learned that if we have a constant divided by infinity, we can simplify this as 0 value. So our final answer here will be 1. Now, for part B, we have limit of x approaches negative infinity of 8x plus 3 divided by 5 minus 2x. Same as before, try to directly substitute your limit value into your function first. In this case, there is no point since we still get infinity over infinity as our final answer. Now, try to manipulate the function. So, divide both parts by the highest power of denominator. In this case, our highest power would be x. Now, every single term in our question must be divided by x. We have limit of x approaches negative infinity of 8x divided by x plus 3 divided by x over 5 over x minus 2x divided by x. Now, simplify your function. X over x can be cancelled out. So now rewrite back the simplified version. We will have limit of x approaches negative infinity of 8 plus 3 over x divided by 5 over x minus 2. Now, we can directly substitute once again the limit value into our function. We will have 8 plus 3 over infinity divided by 5 over infinity minus 2. Constant over infinity can be simplified as 0. So, this will result 8 over negative 2. Our final answer would be negative 4. Part C. We have limit of x approaches positive infinity of 6 minus 5x divided by x squared plus 1. Directly substitute, you will have infinity over infinity indeterminate case. Now, divide every part by the highest power of denominator. So, our highest power in this case is x squared. So, this would be equal to limit of x approaches positive infinity of 6 over x squared minus 5x over x squared divided by x squared over x squared plus 1 over x squared. Now, simplify your function. X over x squared can be simplified. Rewrite it back, so this will be equal to limit of x approaches positive infinity of 6 over x squared minus 5 over x divided by 1 plus 1 over x squared. Now, you can directly substitute your limit value into your function. So, you will have 6 over infinity minus 5 over infinity divided by 1 plus 1 over infinity. Same as before, constant over infinity can be simplified as 0. So in this case, you will get 0 over 1. So our final answer would be 0. Don't be surprised, you still can get 0 as your final answer. Next one. Part D, we have limit of x approaches negative infinity of 3x squared plus 1 over 2x minus 3. Infinity over infinity indeterminate case after we try to directly substitute the limit. So now, using the same concept, we just have to divide every single term by the highest power of denominator. I repeat, highest power of denominator. In this case, our highest power would be x. So, this would be equal to limit of x approaches negative infinity of 3x squared divided by x plus 1 over x divided by 2x over x minus 3 over x. Now, same as before, try to simplify your function. And then rewrite back your simplified version of the function. We have limit of x approaches negative infinity of 3x plus 1 over x divided by 2 minus 3 over x. Now, you can try to substitute your limit value. So, this will be equal to 3 times infinity plus 1 over infinity divided by 2 minus 3 over infinity. Constant over infinity can be simplified as 0. We will have infinity over 2, and our final answer would be infinity. Don't be surprised, we still can get infinity as our final answer, but not infinity over infinity. And don't forget the sign, since we have infinity from the negative side, so our final answer is negative infinity. Last one, for part E and F, we basically have the same function but different limit value. One is positive infinity and one is negative infinity. Question E and F can be considered as a special case because we have surd of x squared in our function. Bear in mind, in topic 2, you already learned about this. Surd of x squared also can be written as absolute value of x. Now, we know absolute value of x can be defined into two separate functions, which are positive x when our x is greater or equal to 0 and negative x when our x is less than 0. Now, we proceed with question E. So basically, after you try to substitute your limit value, you will get infinity over infinity. So this is still indeterminate case. Our highest power of denominator in this situation is x. But now, in order to rewrite our numerator part, there is a problem since we have a surd there. So, we can choose how to manipulate this situation. X is basically same as surd x squared as we defined before. So for numerator part, we can divide it with x squared since basically we insert our x into the surd function. And for denominator part, there is no changes, so we still divide it by x. Now, simplify our function. X squared and x can be simplified. You will get now, the simplified version would be surd of 1 plus 1 over x squared over 1 minus 2 over x. Substitute your limit value, you will have surd of 1 plus 1 over infinity divided by 1 minus 2 over infinity. Constant over infinity is basically 0, so your final answer here would be 1. Now, there is some difference in part F where we have negative infinity as our limit value. For numerator part, we still apply the same concept, so basically you have to divide it by x squared because we basically insert x into our surd. But for denominator part, we have to divide it with negative x since x is approaches from negative infinity. So x would be divided by negative x minus 2 also divided by negative x. Simplify this, you will get limit of x approaches negative infinity of surd 1 plus 1 over x squared divided by negative 1 plus 2 over x. Now, substitute your limit value, you will have surd of 1 plus 1 over infinity divided by negative 1 plus 2 over infinity. Simplify for the constant over infinity part, you will get -1 as your final answer.